Hello my dear students, welcome to our channel MS2 Physics where physics gets charged. The last video we discussed the electric dipole and its dipole moment and about axial and equatorial line, right? So now in this video we'll discuss the expression for electric field strength at a point P on the axial line of the electric dipole. What does mean by axial line here? The line passing through the center as well as through the charges along its axis. That line is called axial line, and here we are going to find the expression for electric field strength at a point P, which is at the distance of r from the center of the dipole. Okay, so for this, at first we have the electric field strength at a point P due to positive charge which is located at a point B, as well as having the electric field at a point P due to the negative charge which is located at point A. So when I am coming to the direction of this electric field at a point P due to this positive charge, let it be Q1. So as it is a positively charged one, so its direction is away from it is the E1, and this point charge is at the distance of r minus a from the positive charge. Why? Because this total distance is r and this distance is a. When you are subtracting this from this, so you will get this. So r minus a is the distance of that point P from the positive charge, and the direction of electric field at a point P due to this negative charge is towards it, means along PA. Here it is the E2, and this point P is at the distance of r plus a from the negative charge. So now I would like to write the expression for this E1 and E2. At first, electric field strength at a P due to plus Q charge is, we can write E1 is equals to 1 by 4 pi epsilon into Q by BP whole square. Why? Because the distance of P from point B, and this will be acts along B to P only, along BP rightward. So we can write the expression for this E1 as 1 by 4 pi epsilon into Q by BP is a r minus a whole square. Let it, this is the equation 1. And now at the same time we have the electric field strength at a point P due to negative charge is, which is placed at the distance of r minus a. So E2 is equals to, we can write 1 by 4 pi epsilon into Q by the distance is AP. From figure, AP is a r plus a whole square, and let this is the equation 2, and it will be acts along this electric field is acts along P to A bar, means towards leftward, and here it is towards rightward. But these are the expressions for electric field strength due to individual charges of this electric dipole. But we need, our intention is to find the electric field strength due to this arrangement of the dipole. So to get this, means the net electric field strength at a point P due to a given dipole. So here we have the two electric fields. One is the rightward, another is the leftward. So the difference of the two is gives the net electric field. Therefore net electric field is equals to, sir, now you are right, E1 minus E2 or E2 minus E1, sir. So for that you have to check of the E1 and E2 which is the greater one. Just let it tell me which is the greater one here. E1 is the greater. Why? Because the smaller is the distance, more will be the electric field strength. Why? Because E is inversely proportional to r square. Larger the distance, lesser will be the electric field strength. So that I am writing here E1 minus E2, but not E2 minus E1, please, as E1 is greater than E2. So when E1 is greater than E2, the resultant electric field strength is also in the direction of E1. Means can I write E on axial line is also be towards right. Got how I am taking the direction of net electric field at a point P on the axial line. So now to get this, here it is said to be E on axial line. So this is equals to E1 from equation 1 is a 1 by 4 pi epsilon naught q by r minus a whole square minus 1 by 4 pi epsilon naught q by r plus a whole square. So therefore we will get a E on axial line is equals to, by taking q by 4 pi epsilon naught common and here r minus a whole square and r plus a whole square, so we will get the LCM as r square minus a square whole square, so that here we will get r plus a whole square minus of r minus a whole square. Okay students, I am taking q by 4 pi epsilon naught outside and of the 1 by r minus a whole square minus 1 by r plus a whole square, taking the LCM, so that we will get this. So E on axial is equals to q by 4 pi epsilon naught of, this is what, r square plus a square plus 2ra, here it is a minus r square minus a square minus of minus plus 2ra upon r square minus a square whole square. So that here we will get a E on axial line is equals to q by 4 pi epsilon naught of this plus r square minus r square plus a square minus a square get cancel. You will get 4ra by r square minus a square whole square. On rearranging this equation, 1 by 4 pi epsilon naught into, can I write, q into 2a into 2r upon r square minus a square whole square. So that again the product of charge and the separation between these two charges means the length of the dipole is gives the dipole moment, otherwise you will write here q into 2a is the p. So therefore E on axial line is equals to 1 by 4 pi epsilon naught of 2pr upon r square minus a square whole square. This is what the expression for the electric field strength on the axial line of the electric dipole, and it will be acts, the direction is acts along BP only, otherwise towards rightward. This is the way we will get the magnitude and direction of the electric field strength on the axis of the dipole. So now we are going to write the same expression for electric field strength due to short dipole. So in case of short dipole, that is A is very much less than r, when A is very much less than r, this expression will become E is equals to 1 by 4 pi epsilon naught into 2pr upon A is a negligible, so r square whole square is the r power 4. So that E due to short dipole is equals to 1 by 4 pi epsilon naught 2p by r cube. This is what the expression for E on the axial line in the case of short dipole. Means the length of the dipole is negligible as compared to the distance of that point from the center of the dipole here. So now one more important point, bit point of view, what is the angle between E on axial line? Angle between E on axial line and the dipole moment p bar. What is the angle between axial and dipole moment? So from this vector diagram, I got the expression for E on the axial line is towards rightward, and basically the direction of dipole moment, is from negative charge to positive charge, as we discussed in the last video. So here it is, we have the negative charge, this is a positive charge, so the direction of dipole moment is also be rightward. When the dipole moment is rightward, E on axial line is also be rightward, so that angle between the two is a 0 degrees. That is, E on axial line is parallel to the p bar. This is what again we have the same expression in the magnetic dipole. In the case of magnetic dipole, we have this is a south and here it is a north. So at a point P we are considered the distance of again r only, this is a L. So we will get in the case of magnet E on, not E, it is a B on axial line is equals to, there the proportionality constant is mu naught by 4 pi, here 2m into r by r square minus l square whole square is the expression for magnetic field strength at a point on the axial line of the magnetic dipole. Similarly, in the case of short dipole, we have the same again, means the derivation is same, but for competitive side we need the expressions only. So here we will get mu naught by 4 pi 2m by r cube is the same again. Here also beyond axial line is parallel to the m bar. These all are the similarities in the case of electric dipole as well as in the case of magnetic dipole. Thank you students. Thank you for watching. If you like my videos, do like, share, comment and subscribe my channel to get more videos.